Year 12 Methods that comes out of Chapter 6, 6K, forming general solutions to trigonometric equations. On this occasion, I've got a tan question in 6B. But because there's a 2 there, I'd like to move the 2 to the other side first. So the tan of 2x plus pi on 4 equals 2 root 3 on 2, and the 2's will cancel to leave it equal to root 3. So I know that in the first quadrant, theta is going to equal pi on 3 for the tan of theta to equal root 3. And we are positive, so all stations to Collingwood, we're looking at the first and the third quadrant for tan to be positive. And this particular tan function has a period of pi on 2, which means I'm looking for a general rule, so it doesn't matter about how many solutions there's going to be. So I'm going to find a solution in each of these quadrants. That will be pi on 3, and this will be pi plus pi on 3, which is 4 pi on 3. So one solution, one option, and remember there's lots of ways that you can write solutions. It's going to be 2x plus pi on 4, because that's my angle, equals pi on 3 plus 2 pi n, or 4 pi on 3 plus 2 pi n. And now I'm going to use algebra to solve for x. X plus pi on 4 will equal divided by 2. So pi on 6 plus pi n, or divide by 2. So 2 pi on 3 plus 2 pi n. Because dividing by 2, I cancelled with the 4 to leave 2 in the numerator. So that x will equal pi on 6 minus pi on 4 plus pi n, or 2 pi on 3 minus pi on 4 plus, that should be, when I divide by 2, pi n, which equals, putting them all over 12, that's 2 pi minus 3 pi plus pi n, or putting them all over 12 times by 4, 8 pi minus times by 3, 3 pi plus pi n, which gives me the answer of pi n minus pi on 12, or pi n plus 5 pi on 12 will be the general rule for all the solutions to this equation. Now, I mentioned option 1. Looking at option 2, I've got answers in this quadrant and this quadrant. So I have pi on 3, pi plus pi on 3, 2 pi plus pi on 3, 3 pi plus pi on 3, 4 pi plus pi on 3. Looking at a general rule, this is all pi's plus pi on 3, therefore pi n plus pi on 3 will cover all solutions. So I've now got 2x plus pi on 4 equals pi n plus pi on 3, which is x plus pi on 4 equals pi n on 2 plus pi on 6. So x will equal pi n on 2 plus pi on 6 minus pi on 4, which is pi n on 2 all over 12. That's 2 pi minus 3 pi. So I've got pi n on 2 minus pi on 12 will be one general rule that covers all solutions. So now that I've shown you two different ways of coming up with solutions, just a little proof that they're actually correct. If I make n equals 0, this set gives me 0 minus pi on 12 and 0 plus 5 pi on 12. So that gives me those two solutions. And when n equals 1, I get the answers pi minus pi on 12 or 11 pi on 12, and then pi plus 5 pi on 12, 17 pi on 12. So they're the four solutions I get when n equals 0 and n equals 1. I could continue and make n equals to 2, and that would be 2 pi minus pi on 12, which would be 23 pi on 12, and 2 pi plus 5 pi on 12, which is 29 pi on 12. Would I get the same solutions using the other formula? Well, I hope so, because they both give you the same answers. So when n equals 0, I have 0 minus pi on 12, which equals negative pi on 12. Same answer. When n equals 1, I get pi on 2 minus pi on 12, which is 6 pi minus pi on 12, which is 5 pi on 12, and yes, it's the same answer. And when n equals 2, I will have pi minus pi on 12, which is 11 pi on 12, which gives me that answer. So both rules give you all the solutions and give you the same solutions, and they are the solutions to this equation.